Hello everyone, and welcome to the Spark Overview lecture. In this lecture, we're just going to be taking an abstract overview of the Spark ecosystem. We'll discuss Spark in general, how Spark is different than MapReduce, what Spark RDDs are, and what RDD operations are. Don't worry about having to understand all the operations we go through. We're going to be reviewing and covering them all again when we actually begin to program with Spark and Python. Let's talk about Spark in general. Spark is one of the latest technologies being used to quickly and easily handle big data. It's an open source project on Apache and was first released in February 2013 and has exploded in popularity due to its ease of use and speed. It was created around 2009 at the AMP lab at UC Berkeley. So you can see that, relatively speaking, it's a very new technology. However, it's been adopted by many users. You can think of Spark as a flexible alternative to MapReduce. Spark can run on top of existing Hadoop distributed file system infrastructure to provide enhanced and additional functionality. However, Spark can also use data stored in a variety of formats, such as Cassandra, Amazon Web Services S3 storage, HDFS, as I just mentioned, and more. Let's talk about the differences between Spark and MapReduce. We should really be looking at Spark as an alternative to MapReduce rather than a replacement for Hadoop. It's not intended to replace Hadoop, but to provide a comprehensive and unified solution to manage different big data use cases and requirements. MapReduce, in difference to Spark, requires files to be stored specifically in the Hadoop distributed file system. Spark, while it can run on top of HDFS, does not actually require those files to be stored in that manner. More importantly, Spark can also perform operations up to 100 times faster than MapReduce. You may be wondering, how does it actually achieve this huge increase in speed? Well, MapReduce writes most of its data to disk after each map and reduce operation. Spark, on the other hand, keeps most of the data in memory after each transformation. Spark can spill over to disk if the memory is filled. Basically, the difference here, as an abstract point of view, is that MapReduce has to write things to disk or your hard drive, while Spark, on the other hand, can keep most of that data in memory or your RAM. So you can imagine that keeping it in RAM versus having to continually write to disk is much faster. At the core of Spark is the idea of the Resilient Distributed Dataset, or RDD. Resilient Distributed Datasets, RDDs, have four main features. They have a distributed collection of the data, they are fault tolerant, they support parallel operations, so they partition the data, and they have the ability to use many data sources, as I mentioned earlier. Just as we discussed in the last lecture about distributed systems, Spark operates the same way. You have a driver program, which operates a Spark context. That communicates with a cluster manager, which then communicates to the worker nodes, which actually execute those various tasks, or whatever your computations you ask on that distributed data. Here you can see we have the RDD objects themselves, and then you perform a bunch of transformations and actions on those objects. You have the DAG scheduler, which stands for the Directed Acyclic Graph, and then you have a task scheduler, and then you actually have the worker nodes themselves. And just in a general sense, Spark allows programmers to develop complex, multi-step data pipelines using this Directed Acyclic Graph pattern. And it also supports in-memory data sharing across these DAGs, so that different jobs can work with the same data. As far as our work with Spark and Python, we're really only going to be concerned with these RDD objects all the way on the left-hand side. Everything else will basically occur under the hood for us. Resilient distributed datasets are immutable, lazily evaluated, and cacheable. And there's basically two types of RDD operations, transformations and actions. And this is the core of what we're going to be doing as we code with Python and Spark. We'll be coding out transformations and actions on some sort of distributed dataset. The basic actions we're going to take a look at is the first, collect, count, and take actions. Collect is going to return all the elements of the RDD as an array at the driver program. Count is going to return the number of elements in the RDD. First will return the first element in the RDD, and take will return an array of the first n elements of the RDD. So you pass in n as an argument into take. And basically these four actions are going to look like methods when we're actually programming with Python on whatever RDD object we create. Then we're going to have transformations, such as filter, map, and flat map. RDD filter applies a function to each element and returns elements that evaluate to true, just like Python's built-in filter function. RDD map transforms each element and preserves the same number of elements. This is a really similar idea to pandas.apply. You map some sort of function to every element in the RDD. RDD flat map is going to transform each element into 0 through n elements and will actually probably change the number of elements from your original RDD to after you perform the flat map operation. Sometimes there's some confusion between map versus flat map. Let me go ahead and give you two examples to try to clarify this. And don't worry if you don't understand yet, you're going to show a lot more examples when we actually program with PySpark. But for instance, a map operation could be something like this. You could have an RDD with a list of names, and then you want to map an operation that grabs the first letter of each name. That way, before and after the map operation, you're going to have the same number of elements, one first letter for each name element. An example of flat map could be transforming a corpus of text into a list of words. So for instance, in your first RDD, each element is a line of text. And then you can use flat map to actually convert that into a list of words. Now, each element is actually a singular word. So you're going to have more elements after that flat map operation. And again, don't worry, we're going to show a lot more examples when we're actually programming with Python and Spark. Now let's discuss pair RDDs. Often, RDDs will be holding their values in tuples, which will look something like this. They'll have a key and a value. This usually offers better partitioning of data, and it leads to functionality based off of a reduction. So then we're going to have two other methods to use, reduce and then reduce by key. Reduce is going to perform an action that will aggregate RDD elements using a function that returns a single element. Reduce by key is an action that will aggregate pair RDD elements using a function that returns a pair RDD. These ideas are really similar to a group by operation. So I want you to keep that in mind when we actually perform the reduce and reduce by key operations when we get to the coding section. Okay, one last note, Spark is continually developed and new releases come out really often. The Spark ecosystem now includes things such as Spark SQL, Spark Data Frames, MLlib, GraphX, and Spark Streaming. So the Spark ecosystem is expanding really quickly, and there's a lot of exciting stuff happening in it. Now that we've learned enough to get started, what we're going to go ahead and do is show you how to set up an Amazon Web Services account to get Spark up and running on the web. We'll also have a text article lecture for some other options in case you don't want to use Amazon Web Services and would prefer to use Spark on your local computer. The reason we're going to show you how to get everything set up on Amazon Web Services is because the whole idea of Spark is that you can no longer use a local machine. You need to use some sort of distributed set of machines that you access through some sort of cloud service, and Amazon Web Services is by far the most popular cloud service. If you're just using Spark on a local computer, you may as well just use something like SQL or just pandas like we've already done throughout the course. Okay, so coming up next is just a text article lecture with some other options in case you don't want to use Amazon Web Services, but after that we'll dive right back into the video lectures showing you how to set up an AWS account and get Spark up and running. It's a pretty complicated process, so make sure to follow step by step in order to get everything set up correctly. Thanks everyone, and I'll see you at the next lecture.